Hey guys, welcome back to my YouTube channel. Today I'm going to show you a presentation I made about force and motion. Force. Interaction between two items that result in a change in their motion. What effect may forces have on objects? Cause it to move, make it faster, make it slow down, stop it, change its course, and modify its shape. What effect does an object's mass have on the force? So this is a question for you guys. Who was Isaac Newton? A well-known English physicist and a mathematician who discovered the relationship between force and motion in 1687. His three principles of motion are still used today to describe the movement of anything in the cosmos. Newton's first law of motion. A resting item will remain resting unless acted on by an unbalanced force. Unless acted on an imbalanced force, an object in motion will continue to move at the same speed and in the same direction. Newton's second law of motion. The acceleration of an item by a force is stated to be inversely proportional to the object's mass and directly proportional to the force. So I got an equation here. Force equals to mass times acceleration. Newton's third law of motion states that there is an equal but opposing reaction to every action. Sir Isaac Newton's facts. Though best known for his universal gravitation concept in the 17th century, Schuyler was also a mathematician, astronomer, and writer. Depending on the criteria employed, his IQ is estimated to be between 190 and 200. Isaac Newton was born in Woolsthorpe, Lincolnshire, England on January 4th, 1643. Sir Isaac Newton was responsible for many of the concepts of visible light and the laws of motion, well as contributing to the calculus in addition to discovering the laws of gravity, the resistance of an item to changes in its state of motion caused by the application of a force. Momentum equals mass in motion. Momentum equals mass times velocity, and then P equals to mass times volume, momentum. Then conservation of momentum. A scientific principle states that if no external forces act on a system or set of items, the total momentum of the system or group of objects remains constant. This idea applies to moving objects. It is closely related to Newton's third law of motion, which asserts that there is an equal and opposite reaction in every action. And then this is an equation over here. Conservation of momentum in one direction. When two objects interact in the same direction, their total momentum before the interaction equals their total momentum after the interaction. When two objects interact two perpendicular directions, their total momentum before their interaction equals their total momentum after the interaction in both directions. When a force is applied to an item, it changes its momentum. This change could be a change in velocity, such as increase or reduction in speed, or it could be a change in direction. An impulse causes a momentum change. Impulse equals to momentum change. And then there I got an equation and then impulse. Inertia, acceleration. Inertia, the resistance of an object to change in motion. This means that an object will either remain stationary or move in a straight line at a constant speed. Acceleration, the change in speed or direction of an object's movement. Acceleration equals to change in velocity / time. Contact force requires two things to be in physical contact with another, usually caused by physical objects such as when two objects rub against one another, typically localized and impact only the two objects in contact. Non-contact force operates on items with two physical touch and frequently created by energy such as light, sound, and magnetism can impact numerous objects at the same time through action. Objects can be moved and made to interaction with one another. Thank you guys. Please like the video and view all my videos. They're very knowledgeable. And please subscribe to my channel if you want more presentations like this. Bye.